Good evening. So, good evening. So this is good evening to all those who watch live and those who will be watching it later. So this will be just a beginner-friendly class. No memorizing of codes or no heavy things or anything. It is just that we're just knowing what are the basics of the basic things in this. What the G codes and what N codes are. Basically, we are just discussing how we will this is things or anything. It is just that we're just knowing what are the basics of the basic things in this. What the G, how we are going to communicate with the CNC machine. That is the main topic we are going to discuss today. Sound different. Too much sound different. Clear, huh? Okay. Because here there is too much sound. So, now, why does this session matter? Why did we take this session today? The main reason for that is nothing but mostly people doesn't understand how to communicate with the machine. See, just like if you see this machine, the CNC machine, as we in the last class whoever has seen, you would have noticed. I had told about what is CNC machine, what are types of CNC machine, what computer numerical control is, all those things. So, what are these machines? These machines are like, what to say, we are just making them to work for us, but they don't know, they doesn't know what to understand our language. Do they know to understand our language? No, they don't understand our language. So what we should do? We have to tell them through their language. In their language, we have to communicate with the machine, right? Now, why we are doing this? Because G code and M code are the basic thing in a program. In a program, G code and M code are the basic things, and most of the crashes in the CNC are happening because of the programming errors. So once you understand this, what will happen? You can clearly avoid all the mistakes. Right? Now, as I told, the CNC, how CNC, sorry about that. So, what the CNC machine think? As per this thing, the CNC is just a machine. I told it doesn't have its own brain. It doesn't have a brain. It doesn't have a brain. It doesn't have a brain. It even doesn't have a common sense. It doesn't have common sense like humans. What they will do? It will just follow the instructions. It will just follow the instructions what we give, right? So what happens if you write it wrong? If you tell it to go into the wrong direction, it will go. It won't think, if I go there, will it be correct? Will it make any problem? No, it won't think about anything like that. You tell it to go to the right, it will go to the right. You tell it to go to the left, it will go to the left. There is no thinking power for the machine. So we have to always give the proper programming using the G codes and M codes. Then now, human versus CNC thinking. What's the difference between the human and the CNC thinking? So human, I told you, it can adjust. We can see if we are telling, okay, we are driving a car. We know if we go left, it's just like a car driving car. If we go left, there is a dead end. We cannot go there. But what will the car do if they turn the steering to the left? It will automatically go to the left itself. It will not control itself to the right. Right? Similarly, once this machine we have given the wrong details, it will do only the wrong things. And if one mistake is given, all that mistake will again repeat everything, because CNC mostly people use for multiple works of the same thing, right? Now, what are the basic languages understood by CNCs? The CNC, or computer numerical control, can understand only one, the letters. It can understand the numerics. Okay. So it will understand letters, numerics, and this logics only. It won't understand English. It won't understand Kannada, Tamil, or anything. It won't understand. It will understand only the letters and the alphabets. It's alphanumeric. Okay, you can only understand alphanumeric commands. Now, coming to the two main code families. That's our main topic today. One is the G code. Second thing is the M code. What's it? One is G code. Second thing is the M code. What is G code? G code means G code is used for all the movements. For example, go left, go right, go front, go back, go up, go down. All these comes in the G codes. Whereas what is M codes? M codes are the actions, machine actions. What we tell them to go to the for example, if you take the case of a car, it will be like we are telling them to, okay, turn on the headlights, turn on the wipers, turn on the indicators, turn on this, turn on that. All those things will be stop the vehicle, start the vehicle, turn. All those things will be controlled by M codes. So that's a basic thing about G codes and M codes. Now, what are G codes? As I told, what are G codes? G codes are you can tell it's like legs or hands of the machine, which we'll use for tool movement, direction, and the path. To tell the tool movement, to which side, where the tool has to go, which direction it has to go, or which path it has to follow. All those things are decided by the G codes. Now, when you come into the directions, so we have axis, right? Last class also we had discussed. We have axis. What are the axes? We have X, Y, and Z, right? So X will be from left to right, will be the X. Y will be from front to back, and Z will be the up to down. So these axes are called as the main three axes. We're discussing about the three-axis machine. It's a basic topic. So this is three-axis machine. So we have the X will be from left to right or right to left. Then Y will be from front to back or back to front, and Z will be from up to down. Okay, so let's go into the individual G codes. Let's go with the individual G codes. First is the G00. It's known as the rapid movement. This is like, it's like a running. It just runs. It's like it is running. It won't take slowly. It will go very fast. This G00 can also be called as what to say. We can also tell it as it's a enemy of the operator, because this won't take any cut and it will go very fast. So if this G00 doesn't go on top, on full top, there are chances that your job may be rejected, your cutter may be broken, all those things happens. So what happens here? This is G00 is the fastest movement. It will be moving very, very fast. Now, what will happen here? It is just to position, rapid positioning. Rapid means quick positioning, quickly to reach to the. We'll have the center position of the. I need the cutter to reach the center position, or I need the cutter to go up, totally up. that time we'll be using this rapid one, so that in an instant it will completely move without any cutting. So it is the fastest movement, and this thing should be, this is the main thing, is it should be never used near the tool. Now, why? What's the problem? It is dangerous. It's dangerous because it will be going in full speed. The feed will be at full speed it will be going, and we won't be having much control of it. Even though in the machine there will be a setting to control it 25%, 50%, 100%, it will always, even if the 25% will be very fast. So some people even changes 25% to 2%, so that they have a little control over G00. And it has the it has no feed control, and there are high chances of tool crashes, because the tool may come fast. If there is no good height between the material and the tool, the base and the tool, then there are chances that the tool may come and hit the material, and it gets broken. So that's why I told, when you are using G00, the tool should be always at a distance above from the workpiece. Now, next, if G00 is dangerous, which we have to use? So we'll be going for the G01. So G01, what is happening? G01 is like you are going slowly. It will have a control. We will give a control limit. We'll tell go only 200 mm per minute or 1500 mm per minute. Whatever feed we are giving, it will go only at that place, that speed, and it will remove the material. It will just come slowly. It will come slowly and then start removing the material and go. It will remove it. It will keep on removing the material, remove it, and slowly it will go. Because this needs some space, because to remove the piece material, it cannot go in full speed. This is actually very safe and uses feed rate. Whenever we say the G01, we'll be mentioning the feed also. The F word, the feed. The feed also will be mentioned in the G01. Okay. Then next is the feed rate. What is feed rate? Feed rate is, we say, what is the speed, the cutting speed. The cutting speed of the machine is known as the feed rate. At what speed it should cut, it should move for removing the material. That is known as the feed rate. This feed rate affects the tool life and the surface finish. Too much feed, the tool may break, the finish will be low. Slow feed, the finish will be very bad. So we have to always take it in the proper way. So what will happen if it is too fast feed? If the feed is too fast, the tool may break, and there are chances of machine vibrations. And if it is too slow, what will happen if it is too slow? When it is too slow, the finish will be very poor, and the tool will start to rub. The tool rubbing will happen, and it will damage the tool more faster. Understood? Then next we are going. So we saw G01, we saw G02. Sorry, G00, we saw G01. Now we are going to G02. So G02 is nothing but it is the circular interpolation. It's a circular interpolation. Circular interpolation means when the tool, so G01 we go the straight lines. G01 is only for the straight lines, x-axis, y-axis, z-axis. So when it comes to at the corners, sometimes if you need, for example, if you have a radius like this, so from here it will come in G01. Now when it turns, when it has to take a radius, so this is the clockwise direction, we will use the G02 option to tell that you have to go in clockwise direction at this radius. We'll give the radius. And then when it is in the opposite direction, this side is called the anti-clockwise. So just how your clock turns, it is clockwise. and the opposite of that is anti-clockwise. So G02 is used for the clockwise circular interpolation, and G03 is used for the anti-clockwise interpolation. Next, along with G0203, we need always a I and J. Okay, we need a I and J. What is I and J? So I and J is nothing but it is the distance from the x-axis or the distance from the y-axis. Okay, so why are they needed? Because machine needs a center. A round needs a circle. Center defines a circle. So that is where we use the I and the J. Now, see, I will be always x-axis, the distance of x, and y will be the distance from y. I will be the x distance and j will be the y distance. Now, next. So we have told this. Now, first, before starting any of the work, we have to tell the machine which unit we are going to use. Because normally in India, everywhere use millimeters, but outside India, many countries like US use the inches. So in the metric system, when we use mm, we have to always start the program with, we have to mention this as G21. And if you are running in the inches, we will be running it in G20. Why we have to give this? I told you the machine has its own brain. So we have to tell. If we are just telling the numbers, go 10, go 20. So the machine should know whether it is 10 mm or 10 inch. So some people get confused whether G20 is mm or G21 is mm. So how we can easily understand that? Simple. You can do one thing. The alphabetical order. I comes before M, right? So first comes I. So that is why it is G20, and M comes after that. It is G21. Just think of like that. So first it is inch, then it is mm. So G20 is inch and G21 is mm. Okay. Then next is the positioning mode. So we have two types of positioning modes here. One is the G90, which is called the absolute positioning, and G91, which is the incremental positioning. So what is in incremental and absolute? What is the difference? What is the difference? So, see, I need to go from this position to this position. I need to go from this position to this position. From here, I'm starting the work. I'm starting from here. I need to go from this position and then to this position. So we can tell it two ways. How? I will tell from point A to point B. Maybe it is 4 mm, 40 mm, and here it is 60 mm. I can tell that from the cutter, from the 0. First you go till 40 and it will stop here. Then you have to continue till 80. So it will come here. What happened? 0, 40, 80. Like this, when we give from one point, which is the fixed point, to the next points, all the next points will be taken from those points. So when we take from there, like this setup, we call it as absolute. And what is incremental? It's going on increased. From here, I am telling the machine, go 40 mm. Okay, it reached here. From there, I will tell go another 40 mm. Understood? So we are given the 40. Earlier we gave 0, 40, we gave 80. So when 80 it reached here, but here we are telling 0 to 40, then again go 40. This is what is known as the absolute and incremental. Absolute and incremental. So this also has to be very, very much informed. Because why? For example, we have a step like this. So I'm telling from 0 go 20. From 20, I'm going to tell 0, 20. Then I will tell go y-axis, all those things. What will happen? Normally, it will follow the same path. But if I put absolute incremental value with absolute code, this drawing will completely change. What will happen? It will go into the another complete dimension. I will be explaining it in the next class with a drawing which will be very understanding. Okay, now just understand this much. Absolute is from a fixed point and incremental will be from the previous point. From the previous point, the next value will be taken. Then, now, why is G90 safer? I told you we have G90 and G91. So G90, why is it safer? Because G90 is always as a constant fixed point. It has a constant fixed points and you can easily tell, okay, x-axis has to go 50, y-axis it will go 10, and then everything, that constant point, the starting point will be the same. Okay, so we can easily read it. So people mostly stick to G90. Okay, now next thing is the tool height. See, in a CNC machine there will be multiple tools. There will be lengthier tools, there will be lengthier smaller tools, everything, but the base will be the same, right? So we have to give the machine, we have to tell the machine where all the base of the tip of the tool, we mention it as a 0. So we have to always mention where is this tool. So for example, tool 1's 0 is at this height, tool 2 0 will be at this height, tool 3 0 will be at this height. So why? Only then the machine will understand, machine will run it properly. It has to understand the tool length. Okay. Now for that, what we will give? We will always give, we have a tool length compensation. For this tool length compensation, we have a G code for that also. That G code is known as G43. So G43, what they will do? It will activate the webinar. Sorry, it will activate the tool length compensation offsets. Okay, so how we will give this? Normally G43, we'll mention first we will mention the tool number to T01. So when you are using the T01, we'll give us G43H01 or H1. Means we are telling that we have to use the H value, the height of this tool. So G43H1, 2, 3, H1, H2, H3, H4. Whatever is the tool, the same H value has to come here. If we are using tool 1, H should be 1. If we are using tool 24, H value should be 24. Now, let's go to M codes. So as I told, M codes are like, it's like switches. Like what we say in our vehicle and all, we'll tell to switch on the lights, turn on the indicators. All those things are controlled by the M codes. So what are there in this? These are the machine controls like turn on, turn off, turn the machine, turn the spindle on, turn the spindle off, turn the coolant on, turn the coolant off. All these things are controlled by the M codes. So what are the major M codes we use? The major M codes we use are M03 and M05. That is for spindle on and spindle off. Okay, M03 will be for spindle on clockwise direction, M4 for spindle on anti-clockwise direction, which mostly will be using only M3, and the M5 is for spindle off. To turn off the spindle, we will be giving M05. So M03 is spindle on, M05 is spindle off. The next is the coolant control. Coolant control, we have two things. One is the M08. So M08 will be the coolant on and M09 will be the coolant off. To on the coolant has many types. We have the mist cooling, we have the flood coolant, different types. Whatever it is, whichever we have given the system as per that, to totally turn on the coolant, we'll be using M8, and turn off the coolant, it will be M9. Next, why do we use coolant actually? The basic use of coolant is nothing but because we need to reduce the heat. Because when the cutter is turning and taking the material, removing the material, what happens is a friction. There is a lot of friction taking place. and on this friction a lot of heat is getting generated. So metal to metal contact, lots of friction and lots of heat. At that point, what will happen? We have to cool the cutter. We have to cool the material and we have to cool the cutter also. For this purpose, we'll be continuously using the cooler. Second thing, what is that? Second thing, the main purpose of the coolant is we have to remove the chips, the waste material, the waste chips which comes from the outside of the material, that has to be cleared then and there. Otherwise, what will happen? It will get stuck to the flutes of the cutter and it may affect the life of the tool. So that is the reason why coolant is one of the most important thing in a machine. But of course, there are situations when we cannot use coolant, that we have to calculate as per the material. Next is the program end. Once we finish the work, we will be giving the M30 command. M30 command is nothing but end and reset. That means we are telling the machine, okay, by that your work is complete, let's go for the next work. So once M30 is given, the machine will be stopped, the program will be over, and the machine will be ready for the new program. That is the main encodes and decodes of the. Now let's go to a simple CNC program. So I told you the starting on G21 and G90 will give. What is G21? G21 is nothing but we are telling the machine that we are going to use millimeter or mm as a unit for this work, and then we are telling we are using the absolute coordinate system. We are not using the incremental coordinate system, we are using the absolute coordinate system. So that we have given the first two instructions. We are telling that use only mm, and you should use the absolute coordinate system, do not use the incremental coordinate system. Then next we have the center point. Every piece what we will do, we will be centering it. We'll start from the center. So we want the cutter to first come to the center. First the cutter should come to the center. For that, what we'll do, we'll use the G00 X0 Y0. What will happen at G00 X0 Y0? The cutter may be at any point. From that point, it will come in fast way. It will come fastly to the center point, to the Z direction, X0 Y0. If you set X0 Y0, it will come to the exact center or the starting point. X0 Y0 is the starting point. So it will be either in the side or center, wherever we set, it will come to that position. X0 Y0 will be the sorry. So we are told, first we told we are doing in mm, then we told we are using absolute coordinate, and then we are told the machine to go in full speed to X0 Y0 point. Next line, what we'll give? We'll give the tool change also. First we have to give the tool. I forgot to mention here, the tool number will be given. For example, we are giving T01 H M6. M6 is the tool change code. So T01, we will give T01 M06. Then after the tool is given, we will give that take the offset of tool number 1. So we'll tell G43 H01. We told the machine to take that offset, and then we tell go to a height of 50 mm above the Z. Z50 is the height. Okay, so the tool came and stopped. Next, we tell M03 S1200. We're telling the spindle to turn in full speed, turn at the speed of 1200 RPM. Speed will get RPM, rotation per minute, and we are telling it to turn on the spindle at 1200 RPM. Next we say go G01. So here what happens? For example, we have set the top isn't on top. We are telling now it is at 50. Now it will come. Now we have shifted to G01 because we need the cut. So what will happen? It will come slowly at a speed of 100 mm per minute. Then it will come to 0. Then it will go, since you again said -2, it will go 2 mm down. Then it will start with it's a speed of 100. Then we are given G01 x50. Now it's at 0, 0, right? It has gone inside and it will go the positive side to 50 mm. X-axis it will go at 50 mm. Okay. Next. After that, so this is also done. Then we'll give all the coordinates, whichever coordinates has to go, y100, x100, y50, all the coordinates will be given. Once after all the coordinates over, next is you have to stop. The work is over. We'll give if coolant is on, we'll give M09 to turn off the coolant. Then we will turn off the spindle. M05 will be turned off. So the spindle will stop and we will give the M30. M30 means the program is ended. Understood? These are the simple CNC program main things. Now, what we will do after that? What will be done after that? After that, we will do a dry run. What is dry run? Dry run. Why we have to do a dry run? Dry run is nothing but, see, I have to remove this material here. I have to remove this material here. So before removing it, I need to know whether the machine or the cutter is going in this proper way. So when it goes in the dry run, it won't take any cut in the air. Little high, it will just simulate. It will show which path it is going, so that we can check whether it is doing it. It will do properly. That's the importance of dry run. What are the common beginner mistakes? What are the main mistakes a beginner makes? Is a person who starts. What are the main mistakes he does? First thing I told, instead of G20, he may be giving G21. He or she may be giving G21. So the mm and inch gets changed. You know that 1 inch is 25.4 mm. So that change in the unit will change the entire design of the product. Then second thing, we are changing by mistake we give in that height is the offset, set offset. If that also is taken wrong, there are chances that there are too many problems. Sorry. Next, what are the golden rules? Golden rules. The main golden rules are CNC follows only the code. What we tell, what code we enter, that's the only thing the CNC is going to follow. And always think twice before you give the final start. Always think, check, do everything before you finally start the work. The main thing, CNC is logical and clarity is safety. So even if you work with CNC, you have to always give the proper codes, and you should be clear yourself. You should clear yourself. Then only you can provide a safe work. Understand? Now, by this, now I want to thank you for listening all to this class. We'll be coming next Saturday with a new topic, with a more interesting topic. And those who are contacted, please leave a comment so that we can arrange the certificates for you. Any doubts? Please, I'll be waiting for another 5 minutes. Please put in the comment box and we will be solving it.
ಸೈಜ್ ಕರೆಕ್ಟ್ ಆಗಿದೆ ಪಿಕ್ಚರ್ ಸೈಜ್ ಹೇಳಿ ನಾನು
Regarding the dry run, if you want to get more details, if I tell you the dry run, so what can go wrong without the dry run? Without the dry run, the main issues that's going to happen is the tool may crash. Tool may crash because of the wrong set value. Then the wrong offset, there can be wrong offsets, wrong G90, G91, anything, because mistakes are common by humans. So at that time, to check this, how much ever confident you are, you have to recheck it. That's why the dry run is very important. Okay. Any other doubts?